All right, so I'm Caleb Mitchell, like I said. I'm in the stormwater engineering group, and I'm studying a subsurface flow gravel wetland. So these things are innovative in the fact that we are keeping water ponded within the subsurface between storm events. So if you think about the natural hydrology in your soil horizons, you would have infiltration into the soil and then water stored there between storm events, and then when another storm came in, the water would infiltrate and push that water out. So about 2/3 of the stream hydrograph is water that's stored there pre-event as shallow interflow. And what happens when we urbanize and we create homes for ourselves and living quarters, we all need places to live. As here in America, it's very sprawled, and so that urbanization, those impervious surfaces, creates a lot more runoff, and it alters the natural hydrology of our ecosystems. And so we get high hydraulic loads to the streams, and this causes high erosion and degradation and incision. So the stream gets deeper, cutting deeper into the water table and not allowing for as much subsurface storage between storms, and not allowing for that long hydraulic retention time within the soil media and the microbial community. So here with the subsurface gravel wetland, we are creating a confined layer that will hopefully keep water there and not allow it to infiltrate down. And then we are putting gravel on top of that, and then a growing media, in this instance sand, as you can see in the top right. There's a pseudo cross section, so we have some bigger stones, then a choker stone, and then a sand layer, and then we plant it with a bunch of herbs and shrubs, and those will help with the treatment of the water while it's stored there between storm events before it gets pushed out from the next storm. And so basically we are mimicking the natural hydrology in sort of an unnatural or constructed way. And so the big reason why we want to do it like this is creating that confining clay layer beneath this really high hydraulic conductive media is because, like I said, streams have become incised and degraded and have cut farther into the water table and have not allowed that water to stay within the subsurface for as long. So here we are artificially doing that and creating a shallow interflow zone where the water can have a long hydraulic retention time and be exposed to a lot of the removal mechanisms that are present. So some might say, you've done this before in bioretention cell or in a sand filter. Well, here it's different because we're keeping the water closer to the surface, within 12 inches of the surface, like a natural wetland.